I'm Luana Dufé, Executive Vice President for New Energy Ventures, and I'm extremely happy to have the opportunity to lead our diversification efforts beyond oil and gas. Since our inception as an integrated company in 2017, we've been pursuing innovation to reduce emissions within the conventional energy space. We have also been exploring ways to position TechnipFMC in the energy transition by delivering differentiated solutions and leveraging our core competencies and existing resources. We are ready to accelerate and grow our contribution to this transition, and New Energy Ventures will play a key role for our company in this journey. The global society is committed to reduce emissions towards net zero, and there is a general consensus we need to accelerate this ambitious goal. However, there is no silver bullet to solve this challenge. Success will come through real collaboration. We will need to develop new technologies and solutions faster than ever before, and the ocean will remain a key part of the equation. That said, fundamental to our strategy is our strong belief that offshore will be the next frontier in the energy transition. As you all know, TechnipFMC lives offshore. We even like to say we own the water column. We are the energy architect in subsea, known for our ability to execute and integrate complex systems. Our goal is to be a key enabler of the offshore renewable industry. To get there, we will leverage our subsea and surface expertise, our collaborative and innovative mindset, as well as our demonstrated capabilities in project integration. We will continue collaborating with energy companies and technology providers to bring to market innovative solutions that are best suited for offshore applications, while maintaining an asset-light model within our business. As a result of our evolution in the new energies arena, we are further refining our market approach, which we have defined through three main pillars. Our first pillar is greenhouse gas removal, which for us will begin with CO2 transportation and storage. The second is offshore floating renewables, meaning wind, wave, and tidal technologies. And the third is hydrogen, which will promote better energy management and efficiency through our Deep Purple offering and digital solutions. Now, I will share more details with you on each of our pillars and how TechnipFMC will continue driving real change in the energy transition context as well. Our first pillar is driven by our ability to immediately leverage our surface and subsea solutions and services to make an immediate impact in the emerging carbon transportation and storage industry. The capture industry is maturing for both low and high carbon period sources, but two important questions remain. Where are we going to store it, and how we will get it there? We anticipate that there will be social repercussions from storing significant volumes of CO2 on land, especially in areas of high urban population. We believe one of the safest and most efficient storage locations is offshore, where the carbon can be maintained in naturally occurring reservoirs and saline aquifers. To get it there safely, reliably, and efficiently, we will offer a fully integrated carbon transportation and storage system. Our scope will begin at the central gathering station, where the CO2 will be compressed and monitored throughout the process, and will end at the injection well. The overall system is being designed using our subsea and surface-based technologies, including dry and wet trees, gas processing system, our control and automation platform, as well as our flexible pipes, including the thermoplastic composite pipe from our recently announced Magma Global acquisition. All of these differentiated technologies are needed to address the unique challenges found in CO2 transportation. Beyond project execution, we will also deliver life-of-field services, including well intervention services and real-time performance monitoring of the entire system. From a market point of view, we foresee the US Gulf Coast as one of the first major sequestration hubs, because there are more than 100 facilities in this region, each emitting more than 1 million tons of CO2 per year. Just last month, we formed a strategic alliance with Talos Energy, focused on accelerating the adoption of carbon capture, transportation, and storage. Talos has been selected as the operator of the United States' first major offshore storage hub, and we will work together through the full life cycle of site characterization, front-end engineering and design, execution, and life of field to de-risk project execution, accelerate time to market, and demonstrate real value by delivering cost-efficient solutions. Overall, the alliance combines Talos' strengths in offshore operations and our subsea and surface expertise, technology integration leadership, and life-of-field service capabilities. We have already identified 3 potential projects, with the first commercial opportunity likely to happen in the near future. We believe this pillar will likely be the first one to make an economic impact for TechnipFMC. Now, moving to our second energy pillar, we aspire to position TechnipFMC as the leader of floating renewables industry. Let's start by looking at offshore wind. This energy source has become well established over the last decade and is now the lowest cost energy source in some countries. This industry is built on bottom-fixed wind turbines that are typically installed in shallow waters and close to shore. We're focused on floating wind applications instead. Today, the floating wind market is still emerging, with only 2 projects delivered so far. We contributed to one of them, Equinor's High Wind project in Scotland, during the demonstration phase in 2009 and during the project execution in 2017. Market projections foresee significant growth in this area, going from almost nothing today to an installed base of 30 gigawatts by 2030. While 2030 seems a long way out, to achieve such intense growth during this period, we require differentiated technologies, product standardization, and an integrated approach. And that makes floating wind a natural opportunity for our company for multiple reasons. First, the skills needed to develop these large infrastructure projects are closely aligned to our track record in subsea. Second, we're exploring new technologies that could benefit from our standardization mindset to bring scalability. And third, we're leveraging our extensive experience in project integration, perhaps our strongest point of differentiation. We see strong integration potential across offshore renewable markets, for example, by combining wind and wave, or wind and hydrogen, we could maximize energy generation and efficiency, since the incremental CapEx and OpEx needed is much lower than a standalone product for the same energy generation. And we will approach these new integration opportunities in renewable energies with the new execution model, which we are introducing today as Integrated Offshore Novel Energies, or simply I1. You all know the success of our iEPCI offering for the conventional oil and gas space. And we believe I1 will play a similar role for the new energy mix. By acting as system integrator in a complex and rapidly changing environment, we can play a meaningful role on enabling offshore renewable solutions. Similar to our strategic rationale behind the Talos Alliance, in March, we announced an alliance with Magnora, a Norwegian company, a Norwegian developer with a history in traditional offshore renewable energy projects, to accelerate our presence in this fast-growing market. We will work closely during the conceptual and design phase, allowing us to significantly influence the project economics and development while de-risking project execution. Together, we are actively pursuing new offshore wind opportunities in Scotland and Norway. And in the future, we intend to look for additional opportunities worldwide. Now, regarding wave energy, earlier this year, we announced a partnership with Bombora, a renewable technology company focused on wave energy. Our collaboration with Bombora is also driven by our integrated model, I1, to combine wind and wave technologies onto a single floating structure, therefore maximizing the efficiency of the overall system. Taking the integrated approach even further, we're also exploring ways to integrate wind and wave with hydrogen. Here, we're working with floating power plant to integrate hydrogen into their wind-wave floater structure. This will also serve as a full-scale validation for our Deep Purple offering in an offshore environment, accelerating the technology readiness for commercial projects. This pilot will be executed at Canary Islands, and it is focused on providing power to remote locations. All that said, we see great potential for a more established wind technology to pull through wave and hydrogen energies. Now, I would like to close this pillar talking about tidal energy, where we are also making tangible steps forward. Compared to wind, tidal energy is a more reliable and consistent energy source, generated from sea currents driven by the natural rise and fall of the ocean. We see great potential given its predictability and the need for diversification of energy sources. Here, we have been collaborating with Orbital Marine Power, who we believe to be the most mature of all tidal technology providers, and whose one turbine has been installed and is grid connected in United Kingdom. Additionally, since the development phase of tidal opportunities is likely to be much shorter than floating wind due to the already consented sites in Europe, we expect floating tidal projects to be commercialized much sooner with concrete opportunities beginning next year. Now, shifting gears to our third pillar, we believe hydrogen will become a crucial energy carrier for storage and transportation of energy, and it will play a very important role in bringing reliability, stability, and efficiency to renewable sources. In simple terms, green hydrogen is produced through the electrolysis of water powered by renewable energy. It can be used for decarbonization of heavy industry, domestic heating, transportation sector, or converted to other zero-emission fuels. As announced last year, Deep Purple is our solution for integrating renewable energy with hydrogen to form a complete zero-emission offshore energy system. It can be configured to a specific energy demand and application and includes power generation, seawater treatment, electrolysis, hydrogen storage, and re-electrification. To better address the reliability and efficiency challenges, we have also been developing a digital solution to enable flexible operation of the system during the rapid changes in wind and load. In periods with good wind conditions, energy can be provided either directly to the consumer or used to produce hydrogen, which could be compressed and stored subsea. In periods with no wind, the stored hydrogen can be re-electrified in fuel cells to produce the power needed by the consumer. In this way, power can be delivered consistently and reliably, regardless of wind conditions. Additionally, our unique subsea storage system provides more storage than what's possible with batteries. Each hydrogen storage module can store up to 12 tons of hydrogen, which can be used to generate 200 megawatt-hours of electricity, the energy equivalent of 4,000 electric car batteries. Our hydrogen solution covers two main segments that together represent a total addressable market of 6 gigawatts by 2030. The first is offshore green hydrogen production and subsea infrastructure for coastal applications. Here, offshore hydrogen production will enable the harvesting of wind resources far from shore, where transport of electricity could be challenging. A hydrogen pipeline offers up to 10 times more capacity for energy transfer compared to a power cable. And our subsea storage system can be used to store a large amount of hydrogen close to end markets along the coastlines. The second is off-grid energy systems, delivering renewable and stable power to traditional energy installations and remote islands. The opportunities linked to this market are primarily driven by the need for decarbonization, for example, replacing gas turbines and diesel generation sets. By combining offshore wind and hydrogen, we can enable 80 to 100% reduction in emissions. While giving you more color on our step towards these two main markets, you will see again that the strategic partnerships have been an important part of our strategy in order to accelerate the time to market of our solutions. We've been developing Deep Purple since 2016, and we have made significant progress with the conceptual design. We're now going through an extensive technology qualification phase, where we expect to have our solution fully commercial by the middle of this decade. Earlier this year, we kicked off the Deep Purple pilot project. We have invited energy companies, Vattenfall and Repsol, hydrogen technology companies, and as well a few other partners into this pilot. We're currently in the process of engineering and procuring a small-scale version of Deep Purple, and next summer, we will have a fully operational test pilot at one of our Norway facilities to demonstrate the system and validate our digital solution. In Norway, we're working towards large-scale offshore hydrogen storage as part of the Hardanger Hydrogen Hub initiative. We're working with Statkraft, one of the largest generators of renewable energy in Europe, to qualify the technologies and digital solutions that will make the project a reality. We have received one study grant, and we are in the process of applying for demonstration funding of a full-scale storage model. And in Portugal, we have been working with EDP through their renewable brands to develop an offshore production and transportation system for green hydrogen generated from offshore wind, which we refer to as the Beyond project. This includes the development and integration of modular solutions for offshore hydrogen production and conditioning of export pipelines. As you can see, we're also making significant progress with our third pillar. I would like to close by reiterating that a realistic path to net zero can only be achieved if we all work together. It will require close collaboration from consumers, governments, and business. We will enable and accelerate the technical and economic viability of greenhouse gas removal, offshore floating renewables, and hydrogen. Our success will be driven by leveraging our core competencies and by partnering with our clients and technology providers to develop groundbreaking solutions, and more importantly, by using our fully integrated delivery model, which I introduced today as I1, or Integrated Offshore Novel Energy. We believe I1 will become the industry standard for driving and enabling the development of renewable offshore energy solutions. As you can see, we're making solid and tangible progress in establishing a clear path for TechnipFMC in the energy transition. We're fully committed to playing a meaningful role in this challenging but also exciting transition period. We're confident we have the right competencies, resources, and teams to make this a very successful journey. We're bringing our energy to deliver the energy the world needs. Thank you very much for your time,